This session we are going to discuss about scope of the variables, a lifetime of the variables, global variables, local variables, variables with static keyword usage in C programming. So let us start with directly with an example. So this session is related to functions because the variable scope and lifetime is related to function. This is a function based area. So we'll be writing a lot of functions. So we'll start with header file inclusion. So we have int main. So we will write some functions together. So we'll have a int say fun1. We'll have one more function int fun2. Two functions we have two functions, and we will be declaring variables here. So if it is a global variable, the name global variable suggests that it is having access to every function in the file. So the scope of this global variable is file scope. That means anybody in the file can access the global variable. Say for example int a equal to 10. I'm just putting it like this. So this variable a is said to be global because this is accessible by every function, fun1, fun2, main. Anybody can access. So if you see printf %d, I put a here, and then I can use this printf here too. Okay. So there is in main. In main it is printing a 1\n will put, and then we'll call this function fun1. So if I run this, it's in main, and fun1 function calling is syntaxically wrong. Okay, now main, and then this from fun1. So the basic point is it can be accessed by anywhere in the file. So a is a global variable, it is global to everything. So this one, anybody can access, any function can access this variable. That is why we say it is a global variable. And what is a local variable? Local variable, there are two types of variables, global and local. So I will just type it in. So global variable, here I'll just put it here. This is a global variable. Now if it is a local variable, it is present inside the function. So for example, I am just putting int I equal to 10 here. This is a local variable. Local to fun2. So it is present in fun2. So that is why. So if I put int I equal to 100, this is a local variable to main function. So because this I is present inside this one, so it is local to main. So here I is present inside the fun2, it is local to fun2. I cannot declare one more variable like this, say int a. We cannot declare like this because it's a multiple declaration error. But here I am declaring a I in this function fun2. I declaring a I in this function main. So both are having same variable name, but it is present in different functions. So that's not a problem here because I is a local variable, so it is local to main. So if you declare one more I variable inside this main, it's a problem because you cannot have more than two variables declared. It's a multiple declaration error. But each function is having only one variable. So this I is present in main, this I is present in fun2, this local. So now if I try to print this I here, say print this I here. So which I will be printed, whether it will print this I or this I, it will print this I, 100 will be printed. You see, 100 will be printed, this I value. Okay, so main, so I value in main, this is a value in main, this is fun1 a. So if you print this I, this is this I. Now if this is not there, imagine A is present as a global variable outside. So you see the declaration, it is outside all the functions. That is why we say it's a global. It is outside fun1, fun2 and main. So that's why we say it's a global. But I is not defined outside any function. I is defined in here, it is defined, but this is local to fun2. So in this case, if you compile, it will throw error. So error I is not defined. That error it's a compile time error. It throws a compile time error. So it's needed to be here. So now here you see A is a global variable, A is a global variable, I is a local variable here, this I is also local variable here. Now if I declare int I equal to 555 here, this is a global variable, 555 is a global variable, but this I is a local variable, this I is a local variable. This is allowed. This I is global, these two I's are local to fun2 and main respectively. So this is allowed, not a problem. But now in this case, if I print this I, which will be printed, where this local will be printed or global will be printed? You see, it's printing main I. Main I is in 100. 100 means this I. So it is printing local. So if there is a global I, if there is a local I, you are printing it inside a function. If the local is there, it will give importance to local. It will not print the global. So local gives more priority. Local gets more priority. It's having a higher precedence compared to the global. So if both are there, it will go for local. If only one is there, say for example, if only global is there, it will go for global. If there is a local also, then it will go for local. Okay. So this case, this also, this one. Now in this case, if I print this one, if I just print this I, say for example, if I comment out this one, I comment out this and then I am printing this I. So it is in fun2. Fun2 I, if we try to print by calling fun2. So fun2 it is printing 555. Because 555 is a global variable. Now in this case you see this one, there is I printing, we are happening in fun2. Fun2 doesn't have any internal, so it is obviously going for a global. That's not a big thing. So what you have to remember is, if there is a global and if there is a local, then local gets a priority over the global. That's what you have to remember. Now if this I is also there, then it will print 10 instead of 555 because local is there. That's what. Okay. So this is scope. Scope means the visibility. Scope is visibility. So visibility of A is throughout the file. Visibility of I is also throughout the file. So this visibility is inside this function only. Say for example, we'll have one more. Say for example, M. We'll put M equal to 10. So this visibility of M is only inside the function fun2. So it's a local variable, purely local variable. This is also a local variable. So a variable declared inside the function is said to be local. Okay. Now the next thing is what's called the lifetime. Lifetime of a variable. There are two things you have to remember. One is a scope, other one is a lifetime. Lifetime of the variable means how long the variable is alive. When the variable becomes alive, when it will become dead. That's what the lifetime is. So here in this case, the global variable becomes alive. We are writing a single C file. It's not a project kind of file. It's a single C file. It's having some functions and some variables inside the file. So and this file is having main inside, so which is the starting point for a C program. So that's why we say this is having a file scope and the lifetime is till the program is running. So the lifetime of a global variable is, in this case, lifetime of this global variable A and I are till the program runs. When the program will start, if the main starts, we say it's a program starter. If the main started running, say for example this is line 1, line 2, line 3, likewise the main is running, fun2, it is going to fun2 will run fully, it will return here, then it encounters its braces, ending braces, that means the main is over. Once the main is over, the function is, the program is over. So program is the what is the process? Process is a program in execution. So that's what running means. The program started its execution. So execution is going on, line by line execution is going on, that only we say it's a running. So what's the lifetime? How long this variable is alive? Meaning, what's the meaning of aliveness? Aliveness means the memory allocated. So it is allocated with certain memory. It is available for the access. That's what the aliveness means. Aliveness means how long this will be, this memory will be there allocated. Say for example, this A is allocated with 4 bytes, I is allocated with 4 bytes. How long this will be available? This 4 bytes will be available, and when it is allocated, how long will be there? When it will be gone? That's what this lifetime is. So, for example, this main is there. Main is having int I. This is a local, and when the main started to run, it will allocate this 4 bytes of memory in stack area. And this printing is happening, and this printing of A when the program starts, A and I will be allocated with 4 bytes each, and the program starts itself. So it's a program scope. So a running scope. This how till the file runs, the global variable will be there. That's what the lifetime of the global variable. The program running time. So how long the program runs, how long the main ends, how long the main goes. So if the main ends, the global variable memory will be deallocated by the OS and it will be taken back. So till the main runs, till the program runs, the global variables will be alive. That's what you have to remember. The aliveness. The aliveness is till the program runs. Now see this one, yum. Yum is a local variable to fun2. It's a local to fun2. I'm calling fun2 here. So when the program starts, A and I will be allocated with the 4 bytes each. This I will be allocated only when the function is called. So for this to differentiate this, I will just put I here. So we have I here, which is a global. We have A here, which is a global. We have I here, which is inside the fun1, which is having a value say 500, and we have M here, which is having value say 200, and this is there, right? So when the program starts, A and I will be allocated with the 4 bytes of memory each. So this will be alive till the program runs. When the main starts, nothing will happen. Okay, so there is no memory allocated because it is accessing only A. A is a global variable, so there is no new memory allocation for the function. So it calls fun2. Fun2 is having a local variable yum. So the yum will be allocated with 4 bytes of memory. That means it is coming to aliveness. Allocating memory is coming to aliveness. So when the fun2 is called, yum will be allocated with 4 bytes of memory and it becomes alive. Now only it becomes alive. But when the program is running, when the main is printing this A, there is nothing allocated for yum. There is nothing allocated for this I. For this global I allocated. This is the local I. This is the local I. This is the global I. So when the program starts, these two will be allocated, but nothing will be allocated for this, nothing will be allocated for this, because fun2 and fun1 are not at all called. But when the main is running, fun2 is getting called here. When fun2 call happens, yum will be allocated. So the lifetime of lifetime of this local variable is from the time the function call happens to the function ends. Say for example, the function call happens here. When the function call happens here, the stack will be allocated with 4 bytes. The stack 4 bytes will be allocated for this yum, and the 200 will be stored in that one, and it is working with this thing. So it is printing this yum. Let us see, it is printing this yum, and it is coming out of this ending braces. Once the ending brace is encountered, that means fun2 is over. It is returning to the place of call. So when the function returns, the memory allocated for this m will be removed, will be gone. So that's the use of local variable. So it comes and goes. When the function becomes called, when the function is called, local variables becomes alive. When the function is returned or when the function got over, then local variables will be cleaned out. But the global variable will be still alive till the main ends, because it is having a scope of the file scope, and so it is available for everybody. So that is why it is having a main scope. And now, so I think now you got the picture. So the lifetime of local variables till the function is alive. That means when the function called to function end, global variables till the program ends, program running starting to program ending, global variable will be alive. So aliveness lifetime refers to allocation of memory, and deallocation of memory. So from the time it's allocated to deallocated, we say it's called the lifetime of a variable. Now one more concept we are going to look at here is static. There is one thing called static. You see this one? I just put a keyword, static keyword. It's a keyword. Static is a keyword in C. So I'm adding a static keyword to which one? A local variable. So to a local variable, int m is there. I'm adding a static keyword to int m. So what's the meaning of static is, without changing the scope, we are going to make the lifetime change. That's the use of static. So you don't change the scope. What's the scope? Where it can be accessed. You see m, where m can be accessed? M can be accessed only inside the fun2. I cannot access m here. You cannot just put a print of m here. I cannot do this. So what's the scope? Where it is accessed. So here m scope is local to fun2. That means all the lines that is present inside the function 2, the fun2, can only access m, can modify, can print, can do whatever, and use it for calculation, can do anything with m. Okay, that's the scope. Scope of m is only inside the function. That's the local scope. Okay, but what's the lifetime? Memory allocation to memory deallocation. When the memory allocation will happen for local variable? When the function is called. When the memory will be deallocated? When the function is over. Okay, now here for example fun2 is called. Static int m is given with the value 200. When the function is over, that m will be removed actually if the static is not there. But if you put a static keyword, even after the function is over, memory will not be deallocated, the data will be preserved. That's the meaning. But the scope of m is still inside the fun2. But once the fun2 for call is over, say for example I'm just giving m equal to 300 here. So print of this call everything. So leave, just comment out this one. Now it started with main. Main is calling fun2. Fun2 is going inside. It's a local variable, so it becomes alive. Static. It's of type static. Int static. In static is a specifier. So m is given with the value 200. Allocated 4 bytes. In the 4 bytes we are storing 200, and then it is printing something, and then we are changing m to 300. Now m is having 300. Now the last line, it is m equal to 300 is the last statement, and the function is over. Fun2 is over. Now if it is not having static, this memory will be wiped out, but it is given with the static keyword. So that means this memory allocated for m will be preserved. It will not be removed. Now what is the m value? M is having 300. So it comes out, it goes. Now if we go here, fun2, again fun2 is called. Again fun2 is called. Now this static int m equal to 200, this is the initialization. This will not happen again, because we already m is this is the thing you have to listen carefully here. We are already given m. First of all, when the fun2 was called first time, m was given the 200 value, and m was updated to 300, and it is of type static. So that means it is preserved with the 300 value. When the fun2 is called again, it will not do this reinitialization. It will not do this because it's of type static. It's having value 300. So whatever the lastly updated value will be there. It will not again go for declaration, communication. This phase will not be happening. So it will be having 300 only. So now in this case, so first time it is 200, 200 is printed, 300 is there. Now when fun2 is called again, 300 will be coming. That's the idea. You see? So what's happening here? See for us. So fun2 is called. M is given value 200. We are printing M is printed with the value 200. Now we change M equal to 300. So once it comes out, this value is not removed. This M is still preserved. It comes out. If it is a normal static, without static means M will be wiped out. There is no M. Again it will start as a fresh next time, M equal to 200. Likewise it will just be going. So next time I am calling fun2. This initialization will not happen. This initialization of M200 will not happen, because it's a static. One time initialization happened already. Now it is M equal to 300. So 300 value that is already there, that is preserved. So this line is not encountered. So it is printing 300. Okay, it's printing 300. Now let us see if this is not there. If this is not static, what will happen? This is not static. M equal to 200. It prints 200. I am just putting M equal to 300. Then again calling fun2. Again it comes here, M equal to 200. It's a fresh, started as a fresh. So fun2 is called, M will be allocated 4 bytes. M is this printed 200. M is assigned with 300, but it can count the last line. So M is wiped out, it's gone. Now again fun2 is called. So newly 4 bytes will be allocated, with stored with the value 200. 200 will be printed. M is 300 is stored again, but we are not using it. Comes out, and memory will be deallocated. You see, it will be printing 200, 200. So what is the static's peculiarity? Static is you don't change the scope. I want to preserve the scope. But I want the data to be preserved. That's the idea. So here whenever we do say M equal to, or you can just say M plus plus, we'll just put M equal to or M plus 100. We'll call fun2 again. See, first to 200, then 300, then 400. So it's preserving the value. It's preserving the value, but the scope is still here. I cannot print here. Printf, I cannot just do percentage D. I cannot. Done. So if we try to compile, see, it throws error. M is not defined. So scope is still there. Scope is inside the function only. Okay. So the scope of the variable is inside the function, but the lifetime is preserved. So lifetime behaves as if it's a global, but the scope is inside the fun2. That's the idea of static. Static is a very, very powerful concept in programming languages. In object-oriented programming and all, we have a static functions, we have static objects, we have a static usage in many places. Now this to start with static means you just have to remember the data is preserved. That's what the highlight. Okay, thanks for listening.